I was just thinking about like how I'm gonna present everything, but he just explained everything, so I don't know what to say now. So today I'm gonna talk about the CCIP read, but before that, I wanna just introduce myself. So I'm Muhammed Tanrıkulu, working in ENS as a full stack developer. So what I'm doing there is like pretty much everything, basically. The integration, the protocol, the governance tooling, and infrastructure. And this is the most favorite handles, like the Tanrıkulu.eth, which is my surname, and Muhammad is my name. And these are the cards that we are printing for, like, whenever we go to the events, we are just printing these cards. These are like a business cards, NFC cards, so you can just, like have your own POP inside and just use it as a business card. Today we're going to talk about like what is ENS, what CCIP read does, and like the key components and the use cases of the CCIP read. And maybe let's first start with like what is ENS. I don't know like how many people knows about ENS, how many people have ENS here. Okay, like it's quite a lot, but still I would love to see more. So the ENS is one of the key components on top of Ethereum, but it's not only for Ethereum. It's basically fixing the UX problem on Ethereum. Because the thing is, like everybody has like some interaction with the wallets, and you see that like there's this alphanumeric characters. They are like super how to say confusing, and also hard to handle because like when you try to send some amount of token, you always have to check, go back again, just to be sure that everything is correct. So what ENS does, or how it started as an idea, basically, it handles these alphanumeric characters for you, and you are able to register your handle on top of or like on chain. And whenever you do a transaction or you want to do a transaction, the wallets that have like in the current ecosystem, like maybe 90% of the wallets are already resolving those names to those addresses. So you don't have to remember anything about your address. And which is how the ENS started. So it's just basically, as it's written, is a distributed, openly extendable naming system based on Ethereum blockchain. And after we realized that it actually has like much more potential, because it's just like a DNS, and it can not only keep the wallet addresses, it can only keep some information about you, some metadata. Like it can be your, I don't know, like for example, social media handles, email addresses, some like information about you, like your avatar and everything. So ENS at some point becomes your Web3 profile. So whenever you interact with any decentralized application, you don't have to provide this information again and again. And when you connect your wallets, all the decentralized applications integrated with ENS retrieves those informations and creating a profile for you. And this is another use case. And the third use case is basically, it's just like a traditional domains. You are able to put any content under any decentralized storage system, and then mapping this to your name. And any browser which is supporting ENS going to host your website in a decentralized manner is going to be more censorship resistant. And today's topic. So it's a CCIP read, cross-chain interoperability protocol. And the read means secure data retrieval. This part going to be a little bit different because what I was thinking and when I'm like how I'm going to tell about going to be like a little bit, how to say, like complicated. So I will just try to simplify it. The CCIP read protocol crafted by the founder of the ENS, Nick Johnson. And if you go to the EIP or EIP-3668, you will find all the information about it. And why we needed that, first maybe I should start with that. So we have this problem that like most of the users were complaining, especially nowadays. You know how the gas fees are high when you try to do transaction over Ethereum. It's always a problem, like especially when it comes to ENS, because like you are trying to register your handle and it's just like $5 amount of Ethereum token. On top of that, you are paying a gas price which is doubles, sometimes like triples the amount, which is not good. And it's not only that, also when you try to put some information on top of ENS, this is another transaction. So like the people were just basically saying that like, okay, like it's fine, it's cool, but at the same time, the cost is amazing. So we were trying to handle this problem. And we were like, the first thing came to our mind is basically like, how can we do that in an efficient way and also trustless way? So we were checking the ecosystem, like if there's maybe some already, like someone solved this problem so we can use it. And the first thing as a solution came to our mind is maybe like, let's move some of the stuff from L1 to L2. So like the gas is cheaper, so we don't have to worry. And there's also some mechanisms to check all this, like the verifications, like numerical proofs and this kind of things, like or the storage proofs, let's say. So yeah, the first question was, without clients having to know how to query every L2, how are we going to do that? Because, yeah, like there are a lot of L2s. But at the same time, like we have a couple of clients, like, for example, in JavaScript, like Ethers.js, VM, or WAGMI, or some others. And for each of them, either you have to go and, like learn about all these L2s and just try to create some implementation and, like contribute to them, which is going to be super, super complicated. So the second question is, we shouldn't create any other additional trust assumptions because we already have a lot of problem with the trust, like the trustless environments and stuff. So if we put something more on top of that, it's not going to be easy. And another thing is without any L1 commits on update. So yes, we want to have L2s, we want to scale, we want to give a better option, cheap option to the users, but at the same time, we want to have like one source of truth. So it's not that just easy to just put your information in L2 and just retrieve it and everything is perfect, because this is how our protocol works. It's just going like in both ways, basically. And we said that, okay, we shouldn't do any update on L1 because otherwise people are going to pay gas. It's nonsense. And without any transactions on query, so it's more or less the same. Like the ENS as a protocol is more rely on reading, not writing. So you are writing once maybe, but then when you retrieve your data or some other decentralized application retrieves your data, they are literally just going to the blockchain and querying about the things, and it's more about reading. So we shouldn't have any transaction on query. And without hard requirements on the L2 capabilities. So this actually connected with the trust assumptions. So, or maybe a little broader. We didn't want to add any additional requirement to any L2 to provide all these things. So this is our problem. It seems not that easy. And we started to check the ecosystem. And we were like, okay, like what we can do about that. And first thing we found is, okay, like there are bridges already between the L1 and L2. So you can just, like move the assets from one to another. Or if I simplify how it works, basically, you have a token in L1, and you go to L2 and tell that, like I want to just switch my tokens here, and your token is locked in L1, and you get a Neve clone minted in the L2 and using it. And if you want to go back, the same procedure reversed. So you are burning your clone token, and your token in L1 is unlocked, and you are using it. So is it useful for ENS? Absolutely no, because as I said, like we are more like relying on the read in the protocol level. So which means that we cannot just clone things and just assume that everything is going to be fine. We should be available in everywhere at the same time. So we should have some sort of solution for syncing between the chains. And then we start to deep dive into this solution. Like, okay, there are bridges. Maybe let's see how they are working. Maybe we can find some part of it, gonna help us. And we came to conclusion that, okay, there is this message passing. Now we are in somewhere. Like the message passing is basically how the token, like when you have the bridging, basically all this communication going through the message passing between the L1 and L2. And this is basically either the signed messages or attestations. Yeah, attestation is a better word, I guess. So we thought that, okay, maybe we can use that, but it's still not really solving our problem. So we deep dive a little bit more. And one of the primitive part of the message passing was basically the verification of the data availability in the chain storage. So basically, when you try to retrieve some information from L2, you use this, the bridges to basically just go from one to another, and in there is something happening. Basically, L2 tells that, hey, I have this, information, I have this token here, and I can prove that it's here. And if I show the proof, and if you are able to verify, you can just let user to use in L1. So you can unlock the token. So we thought that, okay, this is a great idea. We should start with that. And in here, I will just quickly, if you don't look, I'll just quickly pass everything, because I realized that I did a mistake putting my slide in a different way. I just wanted to show this first. So what we came up as a solution is this. And what is this? So this is CCIP read. And how it works, what it does. So there are 3 components you see here, and one of them is the client. It's basically the libraries that you are using, like Ethers.js, WAGMI, and others. And there is a smart contract that we want to interact, and we created a specialized server, which we call as gateway. It's a gateway because anyone can just run it. It's a kind of trustless. And what we do instead of the regular bridging or message passing, we do this. Or anybody who can use the CCIP read can do this. So you are just or your client just calls the smart contract just like any other smart contract call. So it's just some function. And in the regular Ethereum applications, what happens if the chain has this information? It just returns the return data. But in our case, we are returning a specialized error instead of just a revert, because we don't have this data in L1. What we do, we are returning an off-chain data, and this off-chain data has some information, which is sender. At this point is not really necessary. The gateway URL, which is super important. So let's maybe put into a word sentence. So you are asking contract that, do you have this information? And the contract says, I don't have this information, but I have information that where you can find this information. And then it sends you this off-chain lookup error or to the client, and client understands that, gets the URL, asking to the gateway, okay, I need this information. The contract told me that you have this information. And then later, the gateway just checks the sources. It can be either off-chain or on-chain. And in our case, it's L2. And it goes to L2 and says, hey, do you have this information? Yeah, I have. OK, I will get this information from you. And then I will get also the Merkle proof of that. And then it gets the Merkle proof, and it gets the information. And in off-chain data error, we have one other parameter, which is called callback function. It tells that, the contract tells that, hey, you're going to go to this gateway, you're going to get the information, but later you're going to come back to me with that information. I will resolve it for you. And then we are getting the information. In the callback function, we are just checking the Merkle proof if everything's correct. And then if it's correct, we are just returning the result from the contract in L1. And you didn't do any write operation in L1, so there's no gas cost. And later, you are just using the answer. So this is the like most basic version of how I can tell how CCIP read works. And I want to go back just a little and just how it helped us, I just want to show it. So in our case, the ENS works just like this. You have an ENS name, and then when you query the name, it tells you about, yeah, like I know this name, which is registered. And this ENS name has a resolver. And the resolver is a contract, like specialized contract, basically keeping all the key value about you, whatever you want. And then what it does, basically, which field you ask, it just retrieves. So if you are asking about the address of this name, it retrieves the address. If you are asking about the avatar URL, it retrieves that. And now I'll just show you like how we did use in our case. So this is you. This is our contract. And you are asking, hey, I want you to resolve one address because I want to send some NFT because I'm a nice guy. I just want to, like I love gifting. So you're just asking about Tanrıkulu.DappCon.eth. And in the regular contract scenario, it just says, nope, I don't have it. And in the CCIP read scenario, nope, I don't have it, but I know where it is. And then later, it goes to client. Client asks the CCIP read gateway. And based on the scenario, either off-chain or on-chain, it's just, like it just does the thing, basically retrieves the information from wherever it is, and then retrieves back the proof and the information to the resolve callback function, and the resolve callback function tells you, yes, this is the address. And you get the information in the L1 level. So CCIP read, and this gateway is a little bit different. I just want to quickly mention about that. So there are two types of gateway interaction at the moment you are able to do. And those interactions have some limitations. The off-chain interaction, it may require an additional verification mechanism, which you can verify on-chain. And it's not that easy to find the use cases, but they are definitely there, and we are using it actively. And the second thing is data may not be publicly available if it's off-chain. So if any company using that, they can just like have some sort of like private database and keep all the information there. So you will not be able to query all this information. And in the on-chain interaction way, it's not free. In off-chain, it is for sure free. It's just some infrastructure, some like company keeping. So these are the disadvantages. And yeah, this goes super complicated. I will just briefly tell about what it is. Basically, recently the Vitalik posted one blog post about all this, the CCIP read and how ENS can scale. And this is basically Vitalik's take from how we can implement the L2 resolver on top of ENS. So it's when you see the pattern, it's like more or less the same. It's just like a bunch of interaction with the contract and then going back to the L2 and retrieving the information and getting the Merkle proof, as I mentioned. And if you need to, if you want to read, it's just QR code is there for it. And so something more familiar. If you ever interacted with the Coinbase or Lens or Argent before, you are already familiar with the subdomains or how they provide handles to their users. And our ultimate goal is basically scaling to L2s and providing those projects to keep all those records in other layers, basically. And the Argent was one of the first company providing the handles for the ENS users, or the users as is the ENS name. But they were doing on-chain, and right after the gas prices went high, they just had to stop giving the handles, so it was super hard for them. And For Coinbase, it's completely different. If you ever interacted with their wallets, they are just offering free subnames for you. You are just getting a handle. So in their case, they are actively using the CCIP read of chain and basically keeping all the data for you. And for the future, they are probably going to use their base layer. And I think I am out of time. So I just wanted to mention that we are using actively in other places, like the DNSSEC and some other technologies that we have to reduce the gas cost for pretty much anything in ENS. So soon you will have more options to interact with ENS without dealing with the gas prices. That's it.
Thanks very much. We've got some time now for questions. And if there aren't any, maybe I'll say, I hope that this CIP, and there are some.
Yeah, in the example you've shown before with base and lens, etc., subdomains were given on other chains, and the main domain was on ETH. Mm-hmm. Is it also possible with that you have subdomains spread across multiple L2s and L1s? So you have one subdomain on L1 and another one on L2?
So this is right now like in the debate phase, I would say, because like where we are at the stage of like scaling, we are right now developing the L2 resolvers to see how we're going to incorporate with all this syncing and the things. So either we will give an option to users to move their names from one to another, or you will be available in everywhere. So this is still not yet decided, but definitely in the scope.
OK, thanks.
Do we have any other questions?
OK.
Well, I hope this means my ENS name will become available on more than one network.
Yeah, we're hoping to.
Nice. Let's thank the speaker again. And